So there are many ways to build an analysis model in GSA, and I'm just going to show you one of them in this short tutorial. So the starting point is an AutoCAD drawing. So what I've got here essentially is a subframe. So I'm showing in 3 dimensions. I've got the the floor plate that you see there. I've got columns coming down. I've got this, which is going to be our penetration in the slab, and I've got my kind of core walls there with the door opening that you see there. Also, interestingly, I've got the grid lines for the structure defined as well. So in terms of AutoCAD, the columns, the yellow lines, are simply just lines in AutoCAD nomenclature. The red lines, the grid lines, I've defined as lightweight polylines, so the standard polyline type in AutoCAD. The green are essentially closed 2D polylines or heavyweight polylines in AutoCAD. So that forms each of the floor panels, it forms the opening, it also forms the sort of core itself. Now I could have chosen to do the entire floor as one single area. Personally, I don't like that. I just want to have each of my slab bays individually defined. And the reason I'm making an issue of the types of line is that these can all be interpreted by GSA in different ways as we import it, and we'll see that when I open GSA. So just to recap, the yellow lines are standard lines. These will be the columns. The red lines are lightweight polylines, so the normal polyline definition. These are grid lines. And the 2D polylines or heavyweight polylines are the green that I'm using for the floor slabs, the penetration, and the core walls. So that's my kind of AutoCAD subframe starting point. Clearly, you could do the entire building in AutoCAD and import it into GSA. It works exactly the same way as I'm going to show you. It really does depend on how you want to construct the model itself. Of course, you might want to think, do you actually need to build the whole thing in AutoCAD and import it into GSA, or are there other ways to go about it? And part of the exercise I'm going to look at here, the implementation of this into GSA, will consider other ways of building a whole building model without doing the whole thing in AutoCAD first. Again, as I said, it's one way of doing it. In industry, it may be done like this. In reality, if there's more time, you would have ideally the whole thing in Revit that might be imported into your analysis package. In this case, it's GSA, but obviously you could be using something like ETABS. The same principles apply. As I pointed out at the start of this tutorial session, you're not being tested on your ability to use software. It's about understanding structural engineering and converting that into a design. So whether you use GSA or ETABS or any other software package, it's really up to you. It's not about the software package, it's about your ability to design. So it's worth remembering that in the context of the project itself. Anyway, let's look at GSA and what we do with the AutoCAD model. So we've now opened GSA. You might see something like this. Again, just for reference, it's GSA version 10.1 and I'm using build 27. So we want to obviously create our analysis model, and we're going to use the CAD file that we created. So a new model, just putting in some details. And these are going to appear on the output if you so desire. So depending how you set it up, you'll get this. So next, these are basically the defaults. You can have a model in 3D space, a plane model. We're just going to keep it to space. We saw how to set the units last time. These are the default codes, and so on. I'm not going to attach grids and stories in this tutorial, but if you look at the help menu, you can see how they're defined. Essentially, there are ways of defining the levels in a model. Clicking next, again, the default options. There is the generate data using a wizard, so these are quick ways to set up a model. By all means, have a go, see how you get on with that if you wanted to, but that's not what we're going to do. So this takes me essentially to the blank GSA screen. I've got a grid, as you can see, which can be turned on and off. So we want to go to File, we want to choose Import, and we want to choose to import this CAD drawing we created. So I've saved it here. And then I get a series of options. So I've used layers in the CAD model. One's called Andrew and one's called grid lines. There are various other options. Again, if you click on help, you can find out what all these actually are. But these are the two I'm going to use for the purposes of this example. So here is where it matters how you define things in AutoCAD. Importantly, we're going to import things into the design layer. So just to reiterate the point, the analysis layer is where the analysis happens. Yes, you can build things, you can build your model in the analysis layer, but for the purposes of design and creating the model, I'm going to use the design layer. Again, it's very much a way that you choose to work. It's really up to you, but I would recommend using the design layer in the first instance. So there's various ways to import what you did in AutoCAD. So the lines that we did, the columns, essentially I'm going to import those as beam elements, so 1D stick elements basically that can resist axial force and bending. There's no arcs, so that's fine. So you remember I stressed the type of polyline. So depending on how the polyline's been defined in the AutoCAD file, it'll be imported in different ways. So as I said, the lightweight polylines were the grid lines I defined. So I'm going to scroll down, I find grid line, and choose that. There's no 3D polylines, so it really doesn't matter what that says. The 2D polylines are heavyweight polylines. I'm going to import those as 2D members. And I'll come to the distinction between members and elements in a few moments. None of these actually apply to us, but again, if you choose help, you can see what they all do. If I choose next, so depending on your preference, you can choose to shift the origin of your model to 0, 0, 0. Again, it really depends on you and how you've created it. I'm not going to do that, but it's an option. Again, lots of other options here. You can have a look at those in your own time. Now if I choose Finish, and we see this. So remembering the kind of parchment color background means we're in the analysis layer, so we're not really seeing, well, we're seeing the very outline of our model there. If we press Control Alt and D, so again that's the quick toggle between the analysis layer and the design layer, Control Alt D, we can switch to the design layer, and we can then see the model which has been imported. Because I've got the shrink option on, that's why you see the gap between them. If I come over here to the top right, you can see I can toggle shrink on and off, as you see there. I'm going to leave it off just because it's the way I like to look at the model. If I put on the restraint option, you see there's nothing at all there. We've not defined any restraints at all. If I toggle back to the analysis layer, Control Alt D again, although we can see the outline of what we've got in the design layer, there's nothing at all in the analysis layer. So if we try to analyze this, well, nothing would happen because there's no model to analyze. At some point, we need to convert our design layer model into the analysis layer model for the analysis, and we'll come to that in a few steps. So going back to the design layer, you see I've got my slab panels, you've got my walls, and I've got the kind of stick elements. Again, I've not defined any of the properties of these, so we don't really see anything yet. So really it's a matter of personal preference where you start with the model to work on it. So I'm going to turn off the Sorry. I was going to turn off that background sort of square grid, but that reminds me, if you click on the squares that you see at the top, it toggles between the grid lines, the square grid or the square grid and the grid lines itself. If I put on the grid lines and maybe look at the top, you can see the grid lines are in here. So that's why I wanted to import those. Again, it just helps me orientate myself in the model itself. If I toggle the panes, we can see the gateway now is here. I believe it's in geometry. If you choose to go to grid lines, that's the grid lines that we defined in AutoCAD, and as you can see, that's them there. You can obviously add to this. There's various options to add more grid lines by incrementing them, or you can simply edit in the table itself. So for example, if I go C. So you see, the thing is, I've put A, B, C, D in the first three. GSA hasn't actually imported them in the same order. So you can see A is that horizontal grid line, B and C are the two vertical ones. So it's not perhaps as straightforward as just putting in the letters. I imagine it's just the way I define them within AutoCAD. Again, I'm not going to go back and do that, but again, you can see how it works. So I choose OK. You can see that the reference labels I've put in are shown thus. But I'm going to turn all of this off for just now, just so it's easier to see the model itself. I'm using the rotation tool here on the left to rotate my model. My model. If you had a very big analysis model, if you hold down Control and click on a node, then the rotation happens about that point. So again, you can choose to change where you rotate the model about. So one of the nice things, and perhaps if we go to a top view, you can see the indicative mesh layout for the 2D elements. So it's going to be worth at this point talking about the distinction between members and elements. And that's true of whether we're talking about the slab panels that you see there or the sticks, which are going to be the columns. So members are what we design. We design a column, we design a slab, we design a beam. But in terms of an analysis model, your beam, your column, your slab will be divided probably into a whole series of elements. So in the design layer, when we're looking at or thinking of the design process, we're using design elements, beams, columns, slabs, what have you. And then they're converted into analytical elements a bit later on. So we can essentially choose to convert the whole model or bits of it for the purposes of analysis. And again, as I said, we'll come to that, but that's kind of where we're going to. So going back to plan. So I said that the purpose of this square there is to be a penetration. So if I come to the left-hand side, if I choose the Select Elements Members option, and I click on that. So this is maybe a good a reminder of what I said in the first tutorial. Depending which way you drag, you either select everything that the box includes or passes over, or only things which are completely included. So for example, here I'm going from bottom right to top left, and you see it selected the penetration that I've gone over, but also it selected the member itself, this big slab member. But that's not really what I want. If I go from top left to bottom right, you see it's only selected the area there because that's the only bit that's been completely enclosed. And that's what I want. So you see I've now selected this. If I now come over to the right-hand side, I can see well, there's various options here, but we're in the member properties. So this is basically telling me the details of that particular member. It's telling it's property 1, so as you remember from before, that's where we're going to define what our slab, say, thickness is, what the material properties is. But in this case, we want to actually say that that's a penetration. So if we look here, we've got member type. So 2D genetic is just standard 2D elements. That's what I'm going to be using throughout. I'm not really going to be using any of the other element types for the 2D elements. Again, you can look in the help menu to understand those. I'm just going for a very basic, straightforward way of doing the model. But we know I want this to be a void, so this is the option there, 2D void cutter. I press that, and it's essentially indicating that there's now going to be a penetration there. Now these elements that you see in outline look all a bit big to me. Again, I maybe want them to be a bit smaller. So there's various ways of doing that. The way I would approach it, again, is if you come back to the right-hand column, there's an option to set the element size. So I'm going to say maybe 0.3 meters. And again, it changes it on the fly. But maybe I want it to be a bit. Sorry, I'm not quite sure what happened there. I think I selected the penetration and altered its size as opposed to the actual 2D element itself, as opposed to the slab itself. So let's try that again. If we go to this slab there, oops. We select the slab, we go to the element size again on the right-hand column, we say 0.3 and it changes it. So yes, before I'd selected the area there and changed that, and that's what hadn't quite been as I expected. So one of the things you might have seen me kind of struggle with was when I tried to select this slab, the column was also selected. So really at this point, all I really want to be doing is looking at the slabs. So if I turn the view so I can see my floor plate, I see the walls there, the columns, and really all I want to be looking at is these slab elements. So if we go to the left-hand side, is the volume tool we looked at before. If I take the volume going across the slab, the only thing, again going from top left to bottom right, the only thing that's completely enclosed is the slab. So that's now all that's left on the screen. Everything else is excluded. So now I can happily select everything or individual elements and maybe set them all to 0.3. And it changes. I'm not quite sure why it hadn't changed the first time. Again, if you select one area, if you hold down Shift, you can then add to the selection. If you hold down Control, you can then remove an area as well. So we've now got essentially ours a floor plate. Fantastic. The other thing I'm going to do is we've called, or I've defined these elements as property 1, and they're called group 1. So you remember we can define lists, we can define our loading based on lists as well. So I could so I've selected everything there. I could right click as I've just done, and I can do save selection as a list. If I did that, I could then type in a name. I might type in slabs. But what I'm going to do is if I come to the left-hand side, go to general data, lists, I'm going to type a list called slab. It's going to be the member, and it's going to be group 1. And when the elements are created, they will also be assigned the group that we define here. And the reason that's important is we can then assign loading based on the group references. So the point of that is that because we can create our analysis model, maybe put loads on it, but then maybe change the way we want to mesh it. We don't want to assign loads to particular element numbers because they might get deleted and recreated. If we assign loading based on groups, the elements created will always be associated with a group, so then the loading is always applied to them. That sounds a bit maybe convoluted, and I'll explain or show you a bit later when we look at applying the loads. So that's me worked out at least a slab meshing. I'm happy with that. We go back to all again. So maybe now I want to look at the walls. So if I take a view on top, maybe I take a volume there. So what we see is the slab and the walls. So what I see is the slab and the walls. Sorry about that. Now maybe I just want to select the walls. And I could go and take more volumes, but it's just as easy to use the member selection tool, the bar on the left-hand side, and use that to select the members. One thing you might have seen there is that I've changed my tool to the rotate view. You can pan and rotate by either holding Shift and just moving the cursor, or there's the tools there. But even though I've changed the way I'm looking at it, you can see the kind of dark line shows me I've still got my member selected. So if I go back and choose the member selection tool, you see they're still selected. So I've still got the walls selected. So the first thing I'm going to do is change the walls to group 2. So again, I can define those in a list later. So group 2. And I'm also going to set the element size. And again, I'll just choose to set it to 0.3. And again, you can see the mesh has been refined. Now this is our doorway. I want to select that. I want to again assign it to be a void, like so. So now we've got our slab. We've got a fine-ish mesh, which is fine. We've got the penetration defined, and we've got these sticks, which will become the columns when we create the analysis model. Just before I go on, I, as you saw, called the walls group 2. If I go to lists, I can put walls. If you type equals, that just copies the text in the cell above, and G2 group 2. So whether we're in the analysis layer or the design layer, we've got the option up here. We've got the drop down. We can see the lists we've defined. So that's the slab, that's the walls, and back to all. So finally, we've got the columns. So if I click on a column, it's been imported. By default, it's been called property 1. So you remember these are beam elements, so we can type in property beam PB1, hit return. So then all we now see on the screen are the actual columns, or what will be our columns. But let's change those to group 3. As you can, to group 3, sorry about that. Go to lists, columns, type in G3, group 3, and that's it. So we've got columns. Use the plus and minus to cycle through if you want. We've got the slab, and we've got the walls, and we've got the whole model. So that basically is it. In the course of, I don't know, kind of 10 minutes going through this, we've now created a single floor. Now I'm going to go through now how to use that to create a model where that just repeats a map app. As I said, you could do the whole thing in AutoCAD and import it in. I'm just showing you a different way of doing it as much to show you options in GSA. But again, it really is up to you. There's a whole range of ways to build an analysis model. But before we do anything else, the thing I would always recommend is that at each stage in building an analysis, you try to actually run the model just under its own self-weight, for example, just to be sure it actually works. There's nothing worse than spending a huge amount of time building a big analysis model, getting to the end, trying to analyze it, and finding it just doesn't run, and then having to spend ages trying to understand why that is. So what do we then do? What's the next step? So I mentioned that when I'm working in the design layer, if I go back to the analysis layer, you see we can see the outline of what's in the design layer, but there's no elements there. There's nothing to analyze. So what we want to do is if we go to Model, Coordination Tools, then Create Elements from Members. So this is essentially going to take what we've defined in the design layer and convert it into an analysis model. So you could do them one at a time. You could choose to do them all. Perhaps you don't like the mesh that's created. You might then choose to essentially delete a particular bit of mesh and redo it. Perhaps you add in bits of extra structure, which might mean you need to change the way that the structure is meshed. Again, it gives you the option to kind of redo bits of the model and remesh it. But for our model here, it's the first time we're doing this, so we're going to create elements from all of the members we've defined in the design layer. If we hit OK. And there is what you might expect to see, a fairly traditional analysis model. So you see we've got our 2D elements. I'm holding Shift and my middle mouse button kind of spins this around. But again, you could use the rotate tool. If I take off the shrink, we can see the slab. Although there's no properties defined, if we hit the section display button that I'm pointing at now on the top right, we can kind of see what we've defined. We can see we've got our penetrations as we expected. We've got the penetration there. We've got the door penetration, and we've got the sticks. But again, there's no properties actually defined, no thicknesses, no section properties. So that's maybe the next thing I'm going to do. And again, I think one of the really good things, one of the nice things about GSA is that on the Explorer, on the gateway that you see on the left-hand side, it's very much a sequential process. If you are new to the software, just kind of following through this is a fairly good way to go. So we've defined our geometry. These are the kind of default material properties. You've, in the preferences, set what your defaults are. So if you don't put in anything else, these will be here by default. And again, it's the kind of standard properties that you would see in the various codes of practice. As I said, if we're not sure what to do when we're entering things, if you press the wizard button, the kind of wand that you see there, it takes you through all the entries that you would need to do if you wanted to define a material yourself. And you can get into more advanced material definitions, perhaps defining orthotropic and isotropic properties for different elements, maybe for deflection type calculations. Again, it's all kind of open up to you in the sort of in the options there. So, but I'll delete that. We'll just stick with the default options. But this is kind of where you would come. And you've got the button along the bottom for the various, the tabs along the bottom for the various materials. In concrete, we've got our analysis and design properties. By default, you'll use the design properties in the analysis. You can, if you want, change it, but we're not going to do that now. For all intents and purposes, we're going to say that the material properties that we see here are what we're going to use in our analysis. So I'll close that just because it's not needed just now. So properties. So for 1D elements, we've got the section library. So you see there isn't anything in here at all. So I'm going to define my columns. So I'll press the wizard button, just because it helps me. And I'll say that the column, give it a name, 300 diameter column. The material, I want it to be concrete. We've got the default grade I specified there. If you wanted a different grade of concrete, you would need to come back to the materials dialog there and put in a different concrete, and then it would appear in the list there. Again, you can define all of this now. You can then come back and alter it again later. Again, there's no restriction on that. If I click on profile, if you've got steel sections, you can maybe go to the catalog and it gives you the the standard steel sections for a given country. We're looking at concrete just now, so it's a 300 diameter column. I've got the kind of units there. It's a circular column I want. So next, put in the diameter. In this case, it's solid. If you wanted a hollow column or a hollow section, you could put it, you could select the option there, but we're not doing that obviously. Click next. It tells me the properties of what I've done, of what I've created, and then just go finish. So that's me defined my 300 diameter column. If I click OK. Now when I want to assign this column, this is associated with property number 1, so PB1, property beam 1. And you can see as you come along here, these are the properties. Again, you can alter these in this table if you want. Also, if you were doing a more perhaps advanced analysis or starting to alter things, maybe to take into account cracking, there's also the option to modify the section, so section modifiers. So if you wanted to say that you've lost maybe stiffness due to cracking in a given direction, you could alter the percentage there. But we're not going to do that for this analysis. The columns are all at full strength. There's no need to alter their stiffnesses or shear factors or what have you. So that's me defined the column. And now the thing that you see is that the elements that we've got for the column show the circular section. So if we go to the left, if we choose the member selection tool, if I click on that, you can see it's telling me that that column is property 1. And property 1, as we know, we've just entered it, is a 300 diameter column. If I go to the drop down now, though, you can now actually see property 1's got the column name on it. So again, it makes it quite easy to assign things. So now we want to actually assign a property to the slabs. So going back to the gateway, the Explorer, we can see coming down, we've got the 2D properties. And again, lots of options here. You can explore them if you wish. Again, the help menu can help, as will the GSA tutorial that's installed with the software. Again, I'm just picking out the ones that I need for this example. So I've got the 2D properties. Again, lots of options. So as before, I'll choose to click the wizard button. So the model, I hadn't said before, the grid's about 8 meters square, I think. So let's say we've got a 275 millimeter thick slab, which seems reasonable. Again, it's concrete. The grade is C3240, and for my analysis, I'm going to use the actual grade itself. As I said before, you can alter the properties that are used in the analysis if you're doing a more kind of detailed analysis. Again, I'm not going to go into that just now, but happy to discuss it if anyone's interested. And then I simply set the thickness there, so 275. I can choose the actual property as well, but I'm setting property 1 here. For the reference surfaces, this is a bit of offsets. I'm not going to go into that just now. Again, you can experiment with that. If I click Next, I can choose if I wanted to apply modifiers. I don't want to. There's no need at this stage. I just want a standard 275 thick slab. If I click Finish, and I've got this. So that's my name. It's property. So property, it's a 2D element. So it's PA, an area element. So property 1 is the 275 thick slab. And that's just the properties that we've input. So all fairly straightforward. Just for interest or reference, I'll put in maybe a meter thick slab. Like so. So again, and this one is property 2. So if we come back to the model, we see this. So you see in the display option there, it's got elements. If I pull the drop down, there isn't anything at all. And that's because in our lists, we defined the lists based on the members. So if I go to member, and I can now see I've got my members defined, columns, the slab, and the wall. So if we just look at the slab for a moment, so you can see I've got my slab. If I click on an element, it's telling me on the right-hand side, it's property 1, group 1. So that's what we would expect. If I turn on the thickness, we can now see it's got a representation of the thickness of the 250 thick slab we defined it as. But if I select everything, if I now change the property to 1,000 thick slab, you can now see it's become much thicker. If I then click on the elements, if I turn off the thickness, if I then click on the elements, you see it's telling me that it's property 2. So that's just a way, obviously, kind of illustrating the effect of changing the property. But I don't want 1,000 thick slab, so I'll change it all back to 275. The other thing is if I put on the nodes, so you've got the annotation tools up here, you've got your nodes, you can put on the nodes that are on the elements. If I shrink them so I can see this. So these are all linear elements, obviously. So as the name suggests there, sort of quad 4, so 4 noded elements. Ideally, I would say, well, I wouldn't use those. I would use 8 noded elements. So for example, we can come in here, we can change them to quad 8, but again, that gives us an 8 noded element in a patch of 4 noded elements. So that's not really what we want to do. I'll use the undo button or Control Z, and that takes that away. What I really want to do is when I create the mesh, I want GSA to create it all using 8 noded elements. Alternatively, I could create it all like that. I could select everything, and I could then change it all to 8 noded elements at the end. But really, I don't like doing that. I'd rather do it all in the design layer as the mesh is created. So that's our model, or at least the small subframe. So the only thing left to do, or only 2 things left to do, is apply restraints and apply loads. So if I do the node selection tool there, just turn on the nodes so I can see where they are. And I want to obviously put in a restraint at the base. So I could select each individually, but why? So if I drag across, I select the nodes at the bottom. You can see them all highlighted there in pink. Again, using the rotation tool, my selection is still there. you can see the blocks. And if I go back to the node selection, it takes me back to that. So if you again look on the right hand side, you've got now the properties of the nodes. So you can define them explicitly, what's restrained, so X, Y, and Z directions and the rotational restraints, or you can use the defaults for the kind of common levels of fixity. So I'm going to say that everything's pinned, or that all of those are pinned anyway. So nothing's actually happened, or you can't see anything on the screen. That's because I haven't got the annotation turned on. So if you come back up to the annotation tools on the kind of top left, on the top right, on the label restraints, if I click that, it now shows me that I've got pins assigned to all of those points. As I said in the first video, I don't like the symbols. I much prefer to see the names or the restraints. If I say selected that node, I can see on the right hand side it's telling me it's a pin with X, Y, and Z. If, for example, I didn't want it to be restrained in Z, for example, I can click that and you can see it's only now got X and Y. So again, you've got a lot of flexibility over how to kind of define the actual restraints themselves. But let's call that a pin. So the last stage of this particular check is I want to actually apply some load to the model to just check it works. And the easiest way to do that is to do a self-weight load case. So if we close up the Explorer, in the bit above constraints, you can see the nodes, members, and elements, and essentially these are all the nodes that we've defined so far. So again, if you wanted to, if you really had time, you could do a script to optimize the whole thing. And in reality, that's perhaps what we would do for a tall tower. We would use maybe Excel or maybe with sort of Grasshopper and Rhino to actually create the model and then import it into GSA. Again, that's fine if you've got lots of time and practice, but you obviously don't have time. So this is a much more pragmatic way of approaching the problem if you just want to do a quick analysis. But back to applying loading. So I've got my loads there. So there's the specification and various types of load that we can apply. So I think it's good practice to actually give the load cases a name. So if we click on load case specification, I can come in here, I can say that that's my self-weight. And because I know I'm going to have various other loads, I'm going to say there'll be a superimposed dead load, and there's also going to be a live load at some point. Now you can define these, but again, that's really not going to come into the model that we're doing. That's really for other features in GSA. Again, feel free to look into it, but that's where we are for this case. So we've got case 1, 2, and 3. Case 1, self-weight. Case 2, superimposed dead load. Case 3, live load. So you see you've got various ways of applying loading to nodes, to beams, to 2D elements, 3D elements, and to grid loading. But I've got gravity loading in mind just now, which is the final option, which is always there by default. So you'd remember there's no elements defined as a list. I've done them all. As members, and I might change that in the next step. But for the purposes of this, we want to apply gravity loading to everything. So if you just hit return, it copies the default value at the top. In the load case, you can see there's the option to assign this to any of the load cases we defined, 1, 2, or 3. And I want the gravity loading, obviously, to be in Z in the negative sense. And that's it. It's as simple as that to define an applied loading. The thing I've not been doing, of course, is saving my model, which I told you you should do very often. So let me do that now. And if I hit, analyze, so a sigma sign there, that should now analyze hopefully. So again, I'm not at this stage defining load cases, load combinations. I've simply applied gravity loading, and I want to check that the analysis actually works. So that's essentially the analysis report. You may remember in my presentation, I talked about, well, should you connect 1D elements to 2D elements and the issues surrounding that, and that's what that sort of warning is pointing out or reminding us of, and I'll come back to that in a bit. But that's analyzed. If I want to actually check that the loads are being applied to this, you remember we can go to the contouring options, we can apply loading or look at loading, 2D element loading, and face pressures. And if I click OK. So this then shows us the load that's been applied. It's obviously all based on the thickness. You can, if you choose the annotation option that I'm pointing at now, you can select that. You can drag over a set of elements, and you can see what the actual value is. Alternatively, if we go back to the contouring options, you've got various options sort of here as to how you're going to display the contours. So obviously they've been rounded, as you can see there, but you can choose to display the contours based on the exact values. So if I do that, if I hit apply, it gives me 6.472, which is the value that you see there. And if you worked out, if you took the density of the material, the thickness of the slab, you would get 6.472. So it's a way of checking that the load has been applied to, and also been applied to the members we think it's been applied to. So if I clear that, so we get back to the model, just to look at the deflected shape again, a quick check of the deflected shapes often tells us whether the model's working as we expect. So that's the deflected or deformed image shape, deformed image button that I'm pointing to now on the top right. If I click on that, you can see the deformed shape. Perhaps if I put on the shading, it's again, as you'd expect, you've got the kind of big spans there deflecting more. You've got the core stiffening it up. So again, it looks broadly okay. If you really wanted to, you can animate it by clicking the Animate button. It does take a bit of time to start, but you can see it slowly moving like so. Perhaps not very useful here, but again, if you're doing presentations, it can be informative. But let's stop that. If we take off the deformed shape, if we take off the shading as well. So that looks okay. One final thing, I'll just look at the bending moments. So that's the buttons that we saw there. I'm not really interested at this stage in setting define contouring. So let's just click on X. That looks fine again, and just looking at how it's spanning, we get kind of peaks over the column supports. One thing that I'd always recommend is that you've got the option to set the middle contour at 0. So that's already been done in these default contouring, in these default contours. But what this tells you is where the point of contraflecture is, which again is very helpful if you're showing both positive and negative values. So on the whole, that looks great. I'm happy with that. And I think that's about it. I'm going to delete the analysis results. I don't really want to carry them forward because we're going to do more on the model. So let's erase results. Let's give me a warning. And that's it. If I save that. The one thing I did realize I forgot to do was change the actual wall thicknesses. So if I come back to the same dialog we looked at before, 2D properties, the walls are 2D elements. So I want maybe, I don't know, it might match, no, let's say 200 millimeter. So 200 thick walls. This time I'm just going to enter it explicitly. So again, by pressing return, it just takes the default values from above. I say that's 200, and so on. So that's my 200 thick walls are property 3. So I go back to the view here, displaying members again. I choose walls, I select everything, and I go to here. Property 3 is 200 thick walls. And again, it's important not to confuse, it's important not to confuse the properties with the groups, the two different things, the two different ways of referencing the model. So if I switch back on the thicknesses, we should be able maybe to see that the walls are a bit thinner than the slabs, which is as we've defined it. So that's created the base model that I'm going to then build on to create the overall building that we're going to look at. But as I said, I've created the elements just as a check that this actually works. I don't want this to be carried forward until I've constructed the model itself. So what I'm going to do is get rid of all this. So if I go back to Model, Coordination Tools, and delete elements from members. So essentially I want to delete the analytical part of the model. And again, I can choose to delete everything or individual bits. So just as an example, if I deleted just the slab, I'm not quite sure that doesn't work. I'm not totally sure what's happening there, but hopefully when I delete elements from members and click all, yes, that's what I was expecting to happen. I'm not quite sure why it didn't delete the individual elements themselves. But that's us now back. There's nothing in the analysis layer. If I do Control D, we're now back to the design layer. So I'm going to then build on this to create a multi-story building with an inclined facade. And that's what I'll do in the next video.